All right, guys. Again, very nice to see you. I hope you had a very good weekend. And of course that you haven't forgotten everything about this class from last week. In the morning, some of the students, well, they were kind of shaky, rusty a little bit since Thursday. Weekend was nice, eventful. You had snow. You might have made snowmen or snow women, and did not mind calculus, but calculus always comes back. So just to remind you guys, I have a website. It's etkin.com, where you find all the information. Syllabi for all my classes are here, a separate folder. Good. And you are always welcome to join any of my sections, either morning or evening or any other time in any office hours. But don't feel pressured. Only if you have questions, if you want, but you're always welcome to be there and participate. Now, the material that I have for this class is stored under Math 150. Good. Math 150 Calc 1, you all have seen it. And you have Advanced Calculus. You see this link? And you have 3 books. In the lower book, Howard Anton, you have Appendix A through Appendix E. And those appendices should give you all the background you need for this class, from nothing to even beyond what you're supposed to truly know. 1 second, give me a moment. By the following creature, if you want to see it. I finally caught it. Here we go. I caught this creature. Now we are going to remove it. Removal of tests. Okay. By the way, you want to see a magic trick? Abracadabra. And here is what happened. You see, look at that. Was a gray cat and I turned it black.
Is that on the final?
Yes, of course. The question is, well, can I make it into a red cat? Right? Am I good enough to make it red? Okay, back to the lecture. So guys, Howard Anton, Appendix A through E is what you should be working if you think you have nothing to work with. Then, of course, you have my lecture notes. They are posted under Calculus lecture notes, and you have what I used to call hand-in assignments. I'm not collecting them. They were hand-in assignments in long days back when I was young and interested in what you write. And this is assignment 1. You can solve limits. We are not even quite there yet. Good. So you can look into the book, which is posted under Advanced Calculus. You can see the middle book, chapter 2 is where we are at. Wonderful, good. Everybody understands, you know where to solve questions, you know what you should be doing. So don't worry, you have plenty of things to think about. And if you want to see how I solve a question, just stay after class. We discuss it all together. All right, let's get going. My Open Math. Oh, thank you for reminding me, guys. How many of you have set up a profile and registered with My Open Math, as I asked in the syllabus? Okay. Okay, you did, and you can use that as a resource. You can do whatever you want with it. I actually never truly looked into My Open Math, but use it as a resource naturally. Good. It is where you will take your final exam. So it's crucial that you set up an account and be registered under me in My Open Math. You've seen the code. You've seen everything. Everybody here can register for that course. Every single one, I mean, every single one here. Yes? So register so you will be able to take the final. Good. Now, let's go and begin with today's lecture. So we are at limits. We covered introduction to limits, and we are now talking about limit laws. Have I mentioned limit laws to you before? No, right? I haven't yet talked about limit laws. Terrible. Well, so in the morning class, I actually have bothered with it. Okay. So here are the limit laws. To prove them, you actually need to understand delta epsilon. And I did go through delta epsilon during my last class, last semester. I will not do it in this semester. I will skip the topic, but I have lecture notes available and videos from previous class and office hours if you want to consider it. There will be a delta epsilon question as extra credit on my first exam. Okay, if that is interesting to you. Last semester, not a single person answered that delta epsilon question correctly, but maybe this time it will be better. Good. It's not a hard question. The problem is that people don't understand what it is, and I can easily test whether you understand or not. It's not just solve, like it's not 2x plus 1 equal to 7, right? It's not like that. You need to think about it and really see something. All right, guys, so limit laws. We are going to, suppose we know that limit as x goes to a of f of x is L, and limit as x goes to a of g of x is equal to m. Would anybody remind me before I continue, what is limit?
I would say it's a number that is, let's say, it's not, let's say for instance, 2, right? So it wouldn't be the exact 2, but it could be 2.01 or 1.99.
Very good. Okay, so that's good. I think you understand the idea. So what you have is when you take limits, you begin with a function. Okay, so first of all, don't forget you have to mention there is a function. And a function is just like a device, like I think of a meat grinder, right? You put something in and it processes what you put in and something comes out. That's what functions do. A function is just an operation that transforms one something into something else. Good? So we are concerned with functions that process numbers into numbers. So for example, Celian Lee, she is making something. She's processing something into something. Same thing we do with functions. Good? Good. So let me remind you of the picture you should have. So you begin with a function, which is a sort of put something in and something comes out. Yes? So you put a number in and a number, something comes out. Could be different, okay? So when I have a specific function like f of x equal to, let's say, x squared, then I can plug into the function 2, right? So I can take f of 2. I have plugged a specific number in, right? And if I plug 2, what happens to it? It becomes 2 squared. There is no x. X just means put in a number and you will get the number squared in that particular instance, right? So 2 becomes 2 squared. Good? And what happens when you take limit as x goes to 2 of f of x? So Abraham, I believe, is saying we are putting something in, correct, Abraham? So you're putting something in, but you're not putting in 2. You are putting approximations of 2. So it's really
1.99.
yes, or 2. I call it 2 hat. You put 2 hat and you will get something out. You put a 2-like number and you get something out. More specifically, guys, here is the picture you should have in mind. It's a good, useful picture. So I was very proud of it. It's a water gun analogy. So if this is 2 and this is my function x squared, right? So when I feed in the input 2, what comes out is 2 squared. So I have exactly one projectile coming out, which is 4. Okay. So evaluating at the function at the number 2 just means launch this particle on the x-axis and make it land on the y-axis. So I think of it as a water particle. It starts at 2 and it lands at 4 on the vertical wall. Good? That's what it's doing. Don't think about the parabola. That's a graph. That's different. That's just that's another way of representing what the function is doing. But the function itself is transforming one number to another number. And this could be done as I drew here. Now, limit gives us an entirely different picture. Okay, this is what I mentioned. I imagine that the water torrent is, well, there is a gap at 2 I'm not allowed to put into, and I'm actually feeding into the function all the particles in the vicinity of 2, and then what happens is that I have a spray current coming around. Good. Now, what do you believe, guys? What do you think is limit as x goes to 2 of x squared? What do you believe this equals to? This is the x squared function. What do you think the limit will be equal to, please?
4.
4. Okay. Now, what is it that you believe? If you believe that the limit is 4, very similar to here. You believe. Would anybody like to finish my sentence? What do you believe about this current of water? You believe that the torrent of water will do what?
It will be somewhere around 4.
Well, good. So the torrent of water, to be more precise, so you see what happens here. Can you picture when you take water and you make it focused? You make the torrent of water very focused, that it looks like it's one linear squared. So it looks like the previous squared, even though it has thickness. Yes, right. So what I picture, and this is basically how delta epsilon will work, is this, guys. So you have, let's make this pipe colored green. So somewhere here is the number 4. And you have a sort of interval, a sort of pipe. Okay, you can make the water go into any pipe, no matter how thin, around 4. You understand the idea? I make the pipe very thin. I can close the domain pipe, and the water will go into that target pipe, right? So the domain pipe I can make as small as I like. This is my domain pipe. The width of the domain pipe represents how good is the approximation. Okay, so for instance, if this is you see, in this case it looks like this interval is going into the pipe, except I mean there is one point missing, right? But if I squeeze this pipe smaller, good, then the current will be smaller and it will enter that pipe around 4. Okay, and I can do that no matter how thin the pipe is. That's how you describe delta epsilon. Okay, we will get back to that idea. So you picture, just for now, without numbers, without anything, is that I squeeze the domain pipe, and then the target pipe is able to eat up all the water droplets, like it all gets into the sink. Can you picture that? And why do I talk about pipes? Is that, look at it, if that target pipe is very thin, it looks like it's just the 0.4. Yes, guys, you see that? If the pipe is so thin, it will eventually look to you like it's the number 4. So that's you're trying to capture the idea of how do you precisely say that you can make the current go into something that looks like 4. So that means you can make the water go into a very, very small drain. Good? Yes, well, fake 4 is all the values in the drain. Okay, could be actual 4, could be fake 4, but it's all the values in the vicinity of 4, so that's in the drain. Good. So make the drain, no matter how small, look at it, this drain looks huge, but imagine you make the drain kind of like this. That's a very, very narrow drain. It's not exactly at 4, but it's very, very narrow drain. If I squeeze the domain pipe small enough, all the water from the domain pipe will land in the narrow drain. You understand? So that's all how limits are working. So qualitatively, it's a very, very different operation than evaluating the function there. Wonderful. So now you see some of those ideas, you need what I just explained to prove them rigorously. You need that analogy or something similar to it, delta epsilon, but you can think intuitively for now, right? So if I know that f of x becomes L and g of x becomes M as x goes to A, of course, then the sum of f and g will be similar to L plus M. Do you agree? F is morphing into an L-like number and G is morphing into an M-like number, and their sum will be L plus M-like number. Seems intuitive, I hope. Good? Similarly with the difference, same thing. Similarly, if I take constant times f of x, right? Factor that constant, everything works very well. And of course, with product. F times G, I'm multiplying L-like number times M-like number, seems to work. Good. It's also similar when I use quotient, except you have to worry, right? Division by 0 is not allowed. So this operation is not going to work when M is 0. I will need to be more clever. Good. So those statements I hope they look to you intuitive and they are true. But to prove that they are true, you need to justify it. Okay. So I really didn't do it with you. Yeah, I didn't do this graph. Okay, here is the limit laws used by a graph, guys. Okay, so can you help me using this picture? Could you please help me calculate what is limit as x goes to -2 of f of x plus 5g of x? So we're doing A. So go ahead, think about it, and I'll begin looking at who is here. Okay, a few of you already have answered it. Kapoor. Okay, wonderful. Thank you, Kapoor. Just wait. Okay. All right. So let's do it now together. We'll take more of this in a moment. Okay. So I really did not do it with you yet. I don't remember, right? With the other class, I did it, I think, on Thursday. All right, so here we go. So first of all, what is f of x becoming? As x goes to -2, here is -2. F of x is the blue curve. It looks like it's becoming 1. Yes? So it looks to me like f of x is going to be a number similar to 1 as x goes to -2. And g of x as x goes to -2 will look similar to 2. Yes? So it looks like 5 times 2. And altogether, I am expecting the number 11. Clear? So I think the number will be 11. Very nice. Everybody's clear? I just use graph and the idea that f is very similar here to 1 as x becomes to -2 and g is very similar to 2. Good. Now, tell me what about b? X is approaching 1. F of x times g of x. Think about what that will be. Or it might not exist, of course, right? You just let me know if it exists or not. Okay. All right, let's work on that together now. Whoa, so let's see what you have said. 6 people replied. So Sophia doesn't exist, does not exist. Very good. So you can see that what's the problem? If I approach from the left, right? So consider this limit first. Consider a limit as x goes to 1 minus f times g. I shorten it, right? F times g. So what is f going to approach if I go to 1 minus? It's going to approach to -2. So it's going to be -2 multiplied by the value of g, which looks like 1. So it's going to be -2. But if I take the limit as x goes to 1 from the right of f times g, from the right, f approaches, you see my pen, it approaches to -1. And g still approaches to 1, so the answer is -1. Left and right hand limits do not agree. Therefore, the limit is not existing. Good?
I'm just having a hard time just following the arrows to get to the points.
Well, I mean, f, right? So f is the blue curve. So if I approach 1 minus, that means I'm traveling to the left of 1 along the blue curve. For just f, I just focus on this thing, right? For just f, 1 minus means I'm approaching to this point from the left. 1 plus on the f, I'm just approaching along the right part of the curve. So I just focus on each of them separately so that they don't confuse me, hopefully, right? And for g, I do the same thing. Now, if I want to examine g, again, I go to 1 minus or 1 plus. I'm now walking on the red curve. 1 minus leads me roughly to 1. 1 plus will leave me also roughly to 1. Yes? So now let's consider the quotient. Yes, they're not touching here, so that you can just, I'm just kind of going about it slower. So f over g, what's the limit as x goes to 2? Let's see if you can say it better than just doesn't exist. F over g. Laforte Tre, are you here?
Yes, I'm here.
Great, thank you. Safa, what's your last name? Thank you, Erin. All right. Elazar, so minus 3 over 0, you want to be more precise about what it is. Do we actually divide by 0? Because then it's undefined. Do we divide by something? Okay, but you might also be saying specifically how undefined. Okay, so sometimes it's not very, yes, good. Infinity might be useful here. Okay, guys, so are we ready to see what happens when we go to 2? So I locate 2 is here. G is going to cause problems. Do you agree? F approaching 2 is it looks like 1. So the numerator 2 plus or 2 minus, look at it. So I will take limit as x goes to 2 minus of f divided by g. Yes? So what is going to be f when I approach 2 from the left? 2 with a minus on top. So look at it. Do you see? I approach along f. You see this, guys? I approach 1. So numerator becomes 1. What does the denominator become? I approach 2 from the left. Look at it. If I approach 2 from the left on g, where am I going? Please help me. You see on the g? I just look at the lower function first. I go to 0, but I need to be more precise how I go to 0. 0 minus or 0 plus? Am I always above 0? Well, look at it. If I approach 2 from the left, I am above the x-axis, so it's 0 plus. Do you see that? So the denominator is 0 plus. If I approach 2 from the left, 2 with a minus, that means the x value is below 2. The y value, the value of g, is slightly more than 0. Do you all see that? Exactly, Sarah. Y is 0 plus. Look at it. Do you see where I'm walking? I am walking, x is walked towards 2 from the left, 2 minus, which means my x is slightly below 2. Now, if x is slightly below 2, g is slightly above 0. Do you all see that? G is slightly above 0, which means it's 0 plus. Do you see that? You might be confused. You see this minus and the plus, it bothers you, but all it says is that x is getting towards 2 from the left. Yes? And if x is going to 2 from the left, g value, that's the red curve, it's a little more than 0. So that would be 0 plus, and the answer 1 over 0 plus is positive infinity. In other words, the limit increases, the numbers increase without stop. They just get bigger and bigger and bigger. On the other hand, what happens if I go towards 2 but from the right? What's the ratio of f and g? The numerator for f is still the same, right? If I approach 2 from the right, That means I'm climbing down towards 1. So the numerator is 1. What is going to happen to g? G, it's here. I am climbing up towards 0. So the denominator is 0 plus or 0 minus? Help me.
Minus.
Exactly, minus. Very good. And that means that I divide a positive number by very small negative numbers, and the answer is minus infinity. Do you see? If I approach from the right, I get minus infinity. From the left, I get plus infinity. The limit does not exist. And the plus infinity or minus infinity means growth without bound. So it's not actual infinity. Good? Let's move on. All right, guys. So let's begin with trying to understand some basic limit laws. Okay? So help me understand what's happening here, guys. If I ask you what is limit as x goes to 3 of 7, what would you have said the answer is?
Seven.
Exactly, it is 7. You see why it's 7? It's because what am I taking the limit of? 7 is the function. Here is what I have in mind. I have a function f of x equal to 7. And I'm taking limit as x goes to 3 of fx. You agree? Now, what is this function doing? This function is transforming every single number into 7, which means it will not only transform 3 to 7, but it will transform any numbers in the vicinity of 3 to 7. So that's obviously 7. Good? You understand what I mean? So the answer is 7 for that reason. You picturing it, guys? I am plugging numbers that are very close to 3, but not equal to 3 when I take the limit. But this function transforms every single number into 7. Therefore, it will transform both 3 and numbers close to 3 into 7. And the limit is obviously 7. Good? Beautiful. Now, tell me then if it's good and beautiful, what in general is limit as x goes to a of a constant of c? That would be, that's a generalization. So if x goes to one number and the function always produces another number, could be a, could be not a, the answer is obviously c. Good? So this is an example of a limit that is very trivial. We don't need much work to understand the answer is c. Okay, so we're building up limits that we can calculate very fast. Good? Next question is hopefully also rather simple. What would you say is limit where x goes to a of x equal to? And why? Okay. Okay, great. We have a lot of answers now. The answer is A, and that's correct. It's tautologically true. Right? The answer is A. Because if x is becoming A, what is x becoming? Obviously A. Tautology means you're just repeating the same thing. X becomes A, so what is x becoming? A. Good? Now help me understand this, guys. What do you think is the limit as x goes to a of x squared? Right? And we are trying to use limit laws. Okay, so limit laws, because I mean, those are the things that if you justify, you know you're correct. It's not just intuition, it's not just your belief, but obviously true. A squared. Now, by limit laws, I know two functions. You see what happens? I can say this is limit as x goes to a of x times x. And the first x I can call, this x I can call f. And the second x I can call g. I know what is the limit of each of them separately, right? Each of them separately is a. According to the limit laws, the limit of the product is the product of the limits. So it will be, I know this limit, I know the other limit, so it will be a times a, which is a squared. Notice just what happened here, guys. That means that when you're dealing with x squared, you can just plug in the number a. Right? A lot of calculus students make this mistake. They say, oh, just plug in the number. Calculate the limit, just plug in the number. It's the same thing. But a limit, you're plugging in numbers close to it. Just the result will be the same as if you just put in a into the function. Good? Easy, right? So similarly, we can now solve what is limit as x goes to a of x cubed. I can reduce it to the limit as x goes to a of x squared, which I just figured above, times x. I know x squared is a squared and x is a. So I get a cubed. Exactly, right? So what I'm doing here, guys, I hope you appreciate it. I'm not thinking why that's intuitive. I'm just quoting recursively the limit laws for multiplication. If this limit law is true, then this must be true. Good? I'm showing you how to just quote the law. But in this class, since it's not an advanced math class, you can just think of it intuitively, even though I hope you will try to understand it from other perspectives as well. More sense than what, Sophia? You said this explanation makes more sense, but that means that you compare to something else, that to some other explanation. All right. So you can continue. Okay. So you can continue, and in general, you can conclude that the limit as x goes to a of x to the n will be a to the n for any positive integer n. Good? Now, we can evaluate this limit and this limit by quoting limit laws. It's a bit tedious, and I don't want to spend too much time on it. I'll just show you quickly how to go through it. And yeah, so you see this, guys, right? Look at it. The limit as x goes to 5 of the first expression, I can break it into sums and differences by the addition and subtraction laws of limits. And then I can evaluate each part individually based on the calculations we carried above. We know that limit as x goes to a of x to the n, it's an easy limit. We can easily figure out what it is. Good? And so I can calculate and I get the answer. I similarly can do the same thing for the quotient. I just use the addition, multiplication, and quotient laws until I get to this step. Okay? So you don't need to do that, and it's very tedious. My main point is that you can see that those results follow logically if the limit laws are true. That's all I'm trying to say, okay? If you were a computer, you could follow step by step sequentially the limit laws, and you can verify without any understanding that this limit is equal to -1/11 by using addition, multiplication, constant, and blah, 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 okay? That's my point. And just to be sure that we're not just using intuition and it's all based on logic. Good. And here again, I mentioned that limits are not the same thing as just plug value in. Okay, it just happens that because you're dealing with right now with very simple functions, that it happens that the end result will be the same as if you just put in the value. But limits can be very difficult to calculate and very unlike the plugging in of the value that is being approximated. So here we are, guys, and now we are going to talk about polynomials. Are we ready? Right? And that's a very, very important discussion, because I will ask you very weird questions that if you don't understand what a polynomial is, it will be like, what are you talking about? I'm going to not only explain, guys, I'm also going to confuse you, right? Because if you are certain, usually you are religious, and religion in places where, you know, you should have doubt isn't good. We're not zealots, right? We want to understand everything that we can. So first is this question: what are the simplest mathematical operations? What's the first thing that you ever learned in school, when, if you can remember, when you began learning mathematics?
Addition.
Exactly, addition. Addition, and let's group it together, especially for me, I was absent in my mind from school. I was elsewhere always. So it was addition, subtraction, and multiplication and division, right? Usually addition and subtraction, they come first, and then you have multiplication, and then you have division. I guess I'm right. Good. So we will, for our purposes, say that addition and subtraction are the same thing, because we know negative numbers, right? Usually they're introduced slightly later, but let's say, what is 5 minus 2? It's the same as the addition of 5 plus minus 2, okay? So if I subtract a number, it's like I'm adding a negative number. So I will say that addition and subtraction is the same operation. It's simpler for me to say so. Good? And multiplication is another operation. Good. Multiplication is another operation. So because those were the first operations you learned, any function that only uses addition and multiplication will be the simplest function possible. Do you agree? So any operation that, because you know those operations, anything that only uses addition and multiplication is the simplest possible machine. You're more familiar with it, okay? So here, look at it, guys. This machine only uses addition and multiplication. Do you agree? Again, remember, I said subtraction is addition of a negative number. Do you agree? This is only using addition and multiplication. Good? Yes, wonderful. Now, any operation that uses, so you see what the x is standing for. The x is the input. So it means give me a number. I will take 5 plus 2 times the number minus 7 times parentheses the number plus 1 plus 2 parentheses number minus 3 squared. Notice I never mentioned the word x, because you have to understand that x is not anything definite. Yes? When I say a statement like all people live less than 100 years, or every man lives less than 200 years, I'm saying that this particular person or that particular person or that particular person, any particular person lives less than 200 years. That's what I'm saying, okay? So x refers to any possible number you can put in. Good. Now notice the following, guys. Do you see that I can group my operations based on the number of times I use the input? Did I use the input at all? Did I use it once? Did I use it twice, 3 times, and onwards? So specifically look at it. I expand this algebra. I group together all the numbers where no x was used. I group together in this expression all numbers where x was used once, x to the power of 1, where you multiplied by x once, and all the operation in which you use multiplication by x twice. You understand? It's just a bookkeeping. I decided to group by the number of times the input is going to be required. So look what I obtained. I obtained that this previous operation is 16, a number, minus 17 times multiplied by the input once, plus 2 times multiplied by the input twice. Are you following me? Can you imagine doing that for any other operation involving addition and multiplication? Yeah, you just carry out, regroup, and track how many times did you multiply by the input. X is that input, okay? Gather together all the operations involving no input, involving input x to the power of 1, involving x times x, x times x times x, and onwards. Good? So then here is the definition of what a polynomial is, guys. A polynomial is a function written as a0 plus a1x plus a2x squared all the way to plus anx to the n, where the number n is an integer that is bigger than or equal to 0, non-negative integer, and where the coefficients, the a1, a2, a3, and onwards, are just numbers. What am I trying to say, guys? I'm trying to say that a polynomial is, that what the definition is supposed to identify is any function that uses only the operations of addition and multiplication. And I make this definition because if I use only addition and multiplication, I can group it in that form. Are you following me? I can group the x's neatly by how many times I multiplied by x. And that will be a polynomial. Okay, and just a brief overview of notation. This symbol means belongs to a set. So when I say a0, a1, a2 onwards is belonging to R, I'm presuming you understand what real numbers are. And we can talk about constructible numbers if you want a geometric intuition for what real numbers are, where it all begins. N stands for natural numbers, which are positive integers, 1, 2, 3, 4, 5, etc. Z stands for all integers, all whole numbers, 0, plus minus 1, plus minus 2, plus minus 3. Why use Z? Because in German, Zahl, die Zahl is the number, okay? Zahl is number in German, so this notation comes from German. Okay, that's how you write Zahl. Okay, now next level is quotients. Q is for quotient. Those are rational numbers. Rational not because they are reasonable, but because it's a ratio. It's a fraction. Okay, next are the fractions. So that would be P over Q, where P and Q are any integers and Q is not 0. And the final category that we consider in this semester, we will venture a little bit into complex if you want. We will see what's the connections there. But as far as we know, that's the biggest category of numbers that you were aware of, I presume. Good. And we have the following. This means belongs to. So we have the natural numbers are subcollection of the integers, which are subcollection of fractions, which is a subcollection of all real numbers. Okay. So that's a very, very brief, very trivial review. I hope it's something that you are aware of. If not, we can, of course, we can talk about it, right? It's not an easy thing, guys. Real numbers were not understood at all until somewhere in the middle of the 19th century, where they were rigorously explained what they are. Okay, and there is so if you study this material on a higher level, you begin with trying to explain what is real numbers, and I can give you an overview of what they are geometrically. Good. So that you have a sense of where the idea is coming from. All right, so next task, guys, is to identify which of the following are polynomials. Are you ready? Let's see how good you are at identifying polynomials. And by the way, guys, don't forget, you tell me in a moment what is a polynomial, because if you identified it, what is it that you identified? Okay, let's begin with the first example. F of x equal to 5. Is this a polynomial? Okay, some people say yes, some people say no. Okay, those words, monomial is just extra vocabulary, we don't need it. Okay, and forget about what you learned in high school. Usually people that go to teach in schools, they don't like mathematics anyhow. Okay, some people say no. I see a wave of no's now. Okay, guys, so you see, that's important. So first of all, would anybody like to tell me what am I asking? When I say, is it a polynomial? Could you very simply explain what am I asking?
It's supposed to have a variable and a constant.
I'm sorry, the sound came kind of muffled. I couldn't understand.
It's supposed to have a variable and a constant.
No. And what's the heart? What's the heart of the idea of polynomial, guys? Even before the definition, what is it that I'm trying to ask? Is it a polynomial? You see function with more than one term. Here we have, that's very vague. Functions with one more, it's very vague. What is a polynomial? Exactly. Functions, guys, here is what it is. Can I describe, have you know programming, right? You're probably far better. I'm like from the 19th century. I cannot do anything, right? But you are young, you understand programming. So the question is, can you program the process using only addition and multiplication? That's pretty much what we're saying here, right? Can you describe the full operation without using anything that is not multiplication and addition? Subtraction is addition of negative numbers, you understand? So we're grouping together addition and subtraction. Good? That's the question. Now look at this function again, f of x equal to 5. Can I describe this operation using only addition and multiplication and nothing else? If the answer is yes, then it's a polynomial. If the answer is no, then it is not a polynomial. And now you're saying yes, correct, right? So here is how I can, if you're forcing me to use addition and multiplication, I can say the following. I can say f of x is 5 plus 0 multiplied by x and plus 0 multiplied by x squared and onwards, right? I can express it with only addition and multiplication. Do you agree? That's it, we're done. It's a polynomial. Clear? You see, guys, it's a polynomial, and you understand what this definition is supposed to capture. Look at it. This definition, it makes no sense unless you understand why you come up with it, right? Here is the idea, you understand? If the operation is using only addition and multiplication, then I can neatly group it by the number of times I multiplied by the input x. Are you with me? So this definition is already using this idea that if it's multiplication and addition that I'm using and nothing more, I can group it by how many times I multiplied by x. And then it has the form that I displayed over there. So it's a constant plus a constant times x plus a constant times x squared plus a constant times x cubed. That's just grouping, okay? But what idea am I trying to capture? That I'm only using addition and multiplication. That's extremely important. If you think I'm just bothering you and nitpicking, no. If you understand this question, I will show you how you can penetrate into the entrails of very complicated functions. You can understand how they work, okay? Good. Next question, guys. G, is G a polynomial? Okay, come on, come on. Okay, a lot of you are saying right away yes, and of course you are correct. It is a polynomial. Do you see it? You see why it's a polynomial, guys? Because I wrote it in the other direction, but you know, some of you write it this way, some of you write it the way I presented it. I will explain to you even why I prefer to write it with smaller power going onwards, okay? There is a reason for it. But yes, it's a polynomial. You can see I only use multiplication and addition, good? And I grouped it based on the x's. Direction, of course, doesn't matter. You can add it one way or another, okay? It sometimes is nicer for the description, it's easier to follow a particular description if you write it one way or you write it another, depending on what you want to emphasize. Good? Are you ready for the next question? Good. So far we're doing okay. Both of them are polynomials. You all understand why, I hope, right? And next question is this: h of x equal to x to the power of minus 2 plus 7x cubed plus 3. Is this a polynomial? So I see a lot of you are saying no. Okay, that's, I guess, good. One person is saying yes, no. Okay, 1 second. Okay. Okay. Are we there, guys? So some of you said no. Okay. Okay, thank you, Safa. We have negative. So here is what some of you have observed. Good? Okay, wonderful. Very nice. Alessandra, very nice observation. So here is what some of you have observed, or maybe many of you have observed. look at it, guys. So the function is f of x equal to x to the power of minus 2. Am I right? Is it plus or minus 7x something? Let me see. My memory is terrible. So plus 7x cubed plus 3, okay. Plus 7x cubed plus 3. This is the function we're dealing with, yes? And Alexandra and a bunch of others notice the following. You see that we are having x to the power of minus 2. And if you remember, if not, guys, of course, review the appendix. And when I talk about exponential functions, I will remind you why that works, okay? Why is x to the minus 2 1 over x squared? So look at it. This is 1 over x squared plus 7x cubed plus 3. And I am using division. I'm not allowed to use division. Yes? You all see that, guys? I'm not allowed to use division, but here I'm using addition, multiplication, and division. And that makes it not a polynomial form. But I have to actually confuse you now. Are you ready? It is not a polynomial form. This function, this operation that is using extra operations, so it's not in polynomial form. But maybe you can deal away with this operation. Maybe you can not use division and just use multiplication and addition and still get the same results all the time. You understand my question? So for example, let's say right now you are in Queens and you want to go to Brooklyn and you can only move by land, okay? You might, of course, take an airplane, fly to Germany. From Germany, you might take the train and go to Poland. From Poland, you might take the plane again to go to Israel. And from Israel, you can return to New York, right? So you use the airplane, but that was not necessary, right? You could have just taken land routes. You didn't have to fly. Similarly, in this problem, how do you know that division cannot be dispensed away with? Maybe you could just avoid using division and only use addition and multiplication and place it into polynomial form. You understand what I'm saying, guys? Just because it does not look like a polynomial doesn't mean you might not be able to write it as a polynomial. Like in programming, you might avoid using certain operations and still be successful in carrying out the calculation. You follow you understand what I'm asking, guys? When I ask, is something a polynomial, I'm asking, can this operation be only described by means of addition and multiplication? Well, I didn't say how. I mean, you see, you're asking me. I mean, you have to be smart, perhaps. Maybe it cannot be done, or maybe if you're smart, you can do it. Let me give you an example of when it can be done. Look at it. Let me just convince you that you have the situation. Suppose we have k of x equal to x to the 4 minus x squared, well, plus x squared divided by x squared plus 1. You agree that I'm using division, yes? So it's not in polynomial form. Do you agree? So many of you might have said, oh, it's not a polynomial, you are using division. But observe what I can do. Observe that in this situation, I can factor out x squared, and here I have x squared plus 1 divided by x squared plus 1. Now x squared plus 1 over x squared plus 1, I can simplify it, and the answer is 1, yes? So this operation can be made more efficient. I can get rid of x squared plus 1, because a number divided by itself, unless the number is 0, remember, unless the number is 0, a number divided by itself is equal to 1. So the answer is that this is just the operation x squared, which is a polynomial. So in this case, I was able to dispense with the extra operations, and I am only using addition and multiplication. Yes? So my question is, how do you know, or can it be done similarly for this problem? Okay, is it true that you can turn any number that isn't in polynomial form into polynomial? So theoretically, all functions are polynomials. Well, we are going to try to discuss this problem. At least we would hope that many things can be represented in polynomials, but I cannot claim this to be true. Okay? You have to be careful. Are you with me, guys? Do you first understand what I'm asking? Right? So you right away dismissed it, many of you, and said it's not a polynomial because it uses division, but you are forgetting this important problem. Maybe I can be smart about it and avoid using division and then make it into a polynomial. Any ideas? Can I do that, or is it impossible? All right. 7x times x squared. Well, be careful, guys. Well, what does it help me? I need to get rid of this division. Okay, still would not be a polynomial, right? But the question is, can I make it into a polynomial, or is it impossible? But if it's impossible, how do you know?
Because she said, it said, Nicole said maybe we can do 7x times x squared. We cannot cross out x squared because it's in the plus form. If it was in a multiplication form, we can, like, the whole polynomial was in multiplication.
But again, you see, there are some conventional things that you cannot figure, and maybe there are non-conventional things. You understand? In mathematics, you have to have imagination. So maybe you take some entirely different route and you will be successful, okay? That's something I will try to show you later in this course, because if you understand what I'm talking about now, you will be able to understand very, very deep ideas, okay? You will be able to understand trigonometric functions with an X-ray vision.
Okay.
Okay. So, okay, to avoid the suspense, to keep it short, the answer is you cannot do it. And you know how I know that? Look, here's my explanation why I cannot do it. I know something about multiplications. Okay, I do, because they're familiar to me. You agree that I can always add and multiply any number. So if I plug in any number, the addition and multiplication will always work. It would always produce a result. Good? But here, what happens here? You understand, guys? If this operation, are you listening to me? If this operation could be carried out with only addition and multiplication, plugging any number into the function will create a number as an output. Do you agree? Because addition and multiplication works with every number. You see my logic? I'm trying to see whether this operation is not able to produce some values. It's not able to digest some numbers. Now look what happens if I plug in 0. If I plug in 0, I have 1 over 0 squared plus 7 times 0 cubed plus 3. And because I divide by 0 squared, this is undefined. This function is not capable of digesting 0. But if it were a polynomial, it will be capable of digesting every single number. Do you understand? So the answer is that it's impossible to make it into a polynomial because of that fact. Because if I could make it into a polynomial, it will be digesting 0. But this function is not digesting 0. You understand how I do it? So I try to verify that it's not just because I'm not clever, it's just impossible to get rid of the division. You follow? And of course, you can still come up with ideas. You have to think very flexibly and very cleverly. Okay, guys, let's go on. Help me with the next expression, k of x. Is k of x, is this function a polynomial or not? Help me figure it out. Okay, some people say yes. Oh, Grant, you joined. It's nice to see you. Exactly, a long time. And tomorrow, hopefully you can prepare for the probability. Okay. So is this a polynomial? A lot of you are saying apparently yes. Erin is saying no. Okay, now let's go and analyze what can happen. You see that strictly speaking, it's not in polynomial form. We have division. Do you agree? The question is, can we get rid of the division? Okay, so let's look at it carefully, guys. Look at this expression. You set it equal, you can factor out x squared, so it's x squared x plus 1 divided by x plus 1. Can I get rid of x plus 1? Is x plus 1 divided by x plus 1 really equal to 1? Not for all numbers. Look at it, x plus 1 can equal to 0 if x is equal to minus 1. So the answer is that this is equal to x squared, but only if x is not minus 1. You see, because if x is equal to minus 1, I cannot simplify it. Good? So for our purposes, strictly speaking, it is not a polynomial because this function is not able to digest minus 1. Good? It's really doing the same as x squared, but it's not capable of digesting minus 1. If you go into complex analysis, naturally, this is such a trivial problem. Yes, there is an exception, right? It's such a trivial problem that it's kind of once you kind of are good at this thing, it's essentially a polynomial. But for our purposes, as you can see, it's not. So I will mark it like this, arrow and not. Strictly speaking, not, but extremely close to a polynomial. You see, because it's like x squared, but only one exception, one small number where it doesn't work. It's a very unnatural exception. Good? And now remind me, I actually already solved this, but is E a polynomial? Yes for E. Wonderful. It's yes for E. You see that E is a polynomial, guys? Why is it a polynomial? Because what happens in this case? In this case, I can factor out x squared, and I have x squared plus 1 divided by x squared plus 1. But look at it, guys. X squared plus 1 never equals 0 for real numbers. Always positive, right? Look at it. If I select 0, 0 squared plus 1 is 1. If I select a negative number, negative times negative is positive. Plus 1 makes it even more positive. Yes? Positive times positive is positive. Plus 1 is positive. By the way, at this moment, you should stop and think, do I understand why negative times negative is positive? I'm not going to discuss it right now, but it bothers me that you just kind of memorize it, right? It makes a very big difference, right? Because if you understand this, then you'll be surprised why x squared plus 1 has a solution which is root of minus 1. What is root of minus 1? Can such a number exist? Right? If you're saying negative times negative is positive, how can you find a number that when multiplied by itself gives you minus 1? Good. But for our purposes, we're right now in calculus. And this I will mention later on what it is. That v of x is a polynomial. So this is a polynomial. Because I can reduce it fully and make it x squared. Yes, because when I cancel x squared plus 1, it's never equal to 0 for any real number. Good. All right, guys. What about f? Is this a polynomial? Look at f. So some people begin to say yes. 2 yeses I see. Is this a polynomial? Do you remember, guys, what it means to take to the power of 1/2? Again, it means square root, okay? Why it means square root, we will discuss once we get to exponentials, but if you cannot wait, we can do it after class. Okay, so this function is 5 root of x plus 2x cubed. Now, do you remember what is root? Root of x means find me a number that if you multiply the number by itself, it will give you x. Okay, So when you say root of 25, root of 25 is 5. For what reason? Because 5 times 5 is 25. So whatever is underneath the root, I need to find a number that when if multiplied by itself, it will give you what's underneath the root. Good? So is this a polynomial? What do you mean, Grant? Is it a polynomial or not? Alessandra, you're going into quantum mechanics. Yes and no, right? The question is it a polynomial? So Erin, no, because it's not defined for negative values. Erin answered it exactly. Look at it. The same idea. You understand, guys? Root by itself doesn't seem like we have an operation for it. We don't know if it's multiplication. But do you see what Erin suggested? If it were a polynomial, if I could come up with a polynomial that does the same thing, you follow, guys? Then it should digest negative numbers. But this operation cannot digest, let's say, -1, because root of -1 is not existing. You see why it doesn't exist, guys? Negative times negative is positive. Positive times positive is positive. 0 times 0 is 0. So you don't have a number that multiplied by itself gives you negative, right? So how is it in mathematics then later on? I mean, it should bother you, right? You should understand why negative times negative is positive. So because then, how do you have imaginary numbers? How do you have this thing? Right? Because root of -1 in complex analysis, it makes perfect sense. You understand how clever it is? You don't ever memorize anything. You have to very precisely understand what is it that you mean, that no number, no root of negative number exists. Good. So everybody is clear? I cannot use negative numbers for any value of x less than 0. As far as real numbers are concerned, I cannot take square root of negative numbers. Jamal, please go ahead. What's your question?
I'm kind of confused because the rules said that the exponent cannot be, the exponent is supposed to be greater than or equal to 0. So how come f is not in polynomial?
Well, you forget, not just greater than or equal to 0, but an integer. 1/2 is not an integer. So it has to be a number either 0 or 1 or 2 or 3 or 4 or 5. So if you see a 1/2 power, it's not a whole number. Yes? And there is yet another idea, guys, right? So you remember, not only by the definition, that's good that you use it, but not only the definition. Do you understand the idea? The idea is that you're only using addition and multiplication, right? That's why the definition makes any sense. That's why the definition is interesting, is that if you're only using multiplication and addition, you can reduce it. You're grouping things together. It's like you're cleaning your room. If you're using operations, multiplication and addition, you can group by the number of times you multiplied by the value x. Okay, that's how you get the definition. Make sense, guys? When you look at the definition, always ask yourself, do you understand why somebody would care to define this quantity? What is it that they're trying to identify? Because if you don't understand that, then the discussion isn't as clear. Can you hear me? Okay, a few more things to say to the topic. So polynomials are very much like integers. They should remind you of whole numbers. They are just as simple as whole numbers. So for instance, guys, we are using a base 10 number system, right? So what is that base 10 number system? Let me show you what it is. So how do you write the number 1806? So you have 6 units plus 0 units of 10 plus 8 units of 10 squared plus 1 unit of 10 to the power of 3. You group objects, you keep them singular until you get a bundle of 10. Then it's one bundle of 10. You see, when you say 10, it's what? It's one bundle of 10. When you say 20, it's two bundles of 10 each. When you say 90, it's 9 bundles of 10 each. But once you get 10 bundles of 10, you make it into one bundle of 100. You understand? You can imagine the matches. You take away the rubber bands and you circle them together. Okay. So if you write 1,806, it's 6 units, 6 matches alone, plus 0 bundles of 10, plus 8 bundles of 10 squared each, plus 1 bundle of 10 cubed. And if you think of the 10 as x, this number is very similar to 6 plus 8x squared plus x cubed. Understand? So there's a very strong similarity between this number and this polynomial. You understand how I'm saying? It's base 10. Okay? If x is 10, then that's the similarity. That will be also useful in some later discussions. Now, guys, what's the next level of complexity? So we dealt with we dealt with polynomials. What's the next level of complexity for functions? Derivatives, well, you're going quite far. What's the next level, guys? I use addition and multiplication. What's the next level of difficulty? What do you learn in school? Addition, multiplication, and then what? Division. Wonderful. So the next level is rational functions. Okay, so we can use now division. So if you use more operations, then you have more complicated functions. So here is an example of rational function where you use quotients. So you have 1 over x plus 2x plus 1 over x squared. You see, how many times did I use division here? I used division twice. Now, I would like to draw to your attention that if you have to use division ever at all, you can reduce it to using division only once. Do you understand? If I have to use division, I can use it exactly once. Let me explain with just, you know that because you dealt with numbers. Okay, let me show you quickly what you did with numbers, right? So suppose you were asked to add 1/2 plus 2/3 plus 5/7, right? So notice that in this fraction, I use division exactly 3 times. Do you agree? Now I can create a common denominator for all of them, which will be what? It will be 2 times 3 times 7. Don't bother simplifying just now. 2 times 3 times 7, yes? So 1/2 requires 3 times 7. So we have 3 times 7 here, plus here we have 2 times 3 times 7. I changed 2 and 7, so it will be 2 here multiplied by 2 times 7, yes, plus here I have 7, and I have 2 times 3 times 7, so I need 2 times 3 times 5. Yes, and when I add them together, look what happens. The denominator becomes 2 times 3 times 7. Here I have 3 times 7 plus 2 times 2 times 7 plus 2 times 3 times 5. My point being that you had 3 divisions and now you have only 1 division. Do you understand? And you can do that with any addition of fractions. I hope you understand that. And same thing you can do in general. You go ahead, somebody raised hands. So whoever wants to start speaking.
I don't even know what you just began to do there when you started 3 times 7 and 2 times 2 times.
Yes.
I'm
So,
not even sure
well,
where you're getting these numbers from.
just an example. I'm just how do you add fractions? You see, guys, how do you add fractions? So how do you add 1/2 plus plus 2/3 plus 5/7? How do you add fractions? Good. Why did I start talking about fractions? Is because I used division 3 times here, and I'm trying to show you that you can use division exactly once. Okay, so I get a common denominator. So it just begin with small. Just how do you add 1/2 plus plus 1/2 plus 2/3? How do I do that? Well, they have to have the same denominator. So I multiply 1/2 to get what's the least common denominator? It's 2 times 3. So this I multiply by 3, and this I multiply by 3. I don't change the fraction. Why did I do that? Is because I'm trying to have the denominator the same. This one is missing a 2. So it's 2 times 2, right? So what did I do? I had 2 divisions, and now I am able to just get 1 division. So that would be 2 times 3 on the bottom. They're all together the same. Numerator is 3 plus 2 times 2. So what I have is 6 here. And here I have 3. I have 3 plus 4, which is 7. So I have 6/7. Notice my point was we started with 2 divisions and we ended up with 1 division. Do we understand, guys? And again, guys, if you are, that's an instance. You see, I mean, one person asked about it, but I know half of the class does not know how to carry those operations. I'm sure of it. Which means that you have to work through the appendix, guys, right? This is prerequisite upon prerequisites. I will do my best to help you with it, but you have to go through the appendix A through E and train your algebra. And of course, I will help you in office hours to try to, as we do limits and do other things, those things will be kind of hopefully trained. I'm hoping that we can catch everything. Good? Good, guys, you understand what I did? I just had a common denominator. I added those fractions, and I had my point. I had 2 divisions, and I reduced it to 1 division. And in my example on top, I had 3 divisions. I made it 1 division. So if you have 100 divisions, you can make it into 1 division. I hope you can see that. So here it is, guys. So 1/x plus 2x plus 1/x squared. Again, I can create a common denominator. Look how I do it. It's the common denominator should be x squared. So what I have here, I multiply top and bottom by x. Here there is the division by 1, so I multiply top and bottom by x squared. You see that? And here I don't need to do anything. So when I combine it, I had 2 divisions. Now I have only 1 division. Clear? Now this gives me the definition of rational function. A rational function is a function that can be expressed as a ratio of 2 polynomials. So there is a polynomial on the numerator and polynomial on the denominator. Do you understand? But what am I trying to capture? Rational function is really an operation that uses only addition, multiplication, and division. Clear? And the reason I make this definition is because I just observed. Yes, ratio comes from rational, right? The reason it's related to smart thinking is because of the Pythagoreans. So when you say you are a rational person, they meant in Pythagoreans had a specific belief about numbers. Good? Are you with me, guys? So you understand what is it that you're trying to capture? You're trying to capture operations involving addition and multiplication and division. And by realizing that you can group it together using only 1 division, you can make this definition. Good? But what it's about is not the form, it's the meaning. It's just what operations you are using. So do you see that this is a rational function? X cubed minus 7x plus 8 over 5x to the 7 plus 8x minus 3. It's it is a rational function because there is a polynomial and polynomial on top and bottom, and really mostly because I'm only using addition, multiplication, and division. Yes? What about polynomial, guys? X squared, is x squared a rational function? X squared, is it? It's obviously I'm not using division, but I'm not forced to use all the operations. So be careful, guys. X squared, I can write it as x squared divided by 1, exactly. So that means it's a rational function. If I can use if I can use division there, then it's a rational function. Okay, and even without making use of it, you have to understand what it means, right? So did you use nothing but addition, multiplication, and division? That's maybe a better way to think of it. If it's true that you use nothing but addition, multiplication, and division, you don't have to use everything. Right? You can use nothing if you want to, right? Let's say 5, you use no operations whatsoever, right? But if you did not make use of operations beyond that, then it's a polynomial, or if it's a rational function, if you're say division. Okay, understand? So you have like a calculator and it has certain operations. You have division, multiplication, and addition. If you use nothing beyond those operations, then it's a rational function. It's a polynomial if you use nothing beyond addition and multiplication. Good? So now we can describe limits. So limits of rational functions. So it is true, guys, that a limit of a rational function is always just you can plug in the numbers just like you did with polynomials, unless the denominator is equal to 0. And the reason is very simple. Limits of polynomials are very simple. Do you agree? Do you see that limits of polynomials, you can break it into limit laws? All of those, just you break it by limit laws, and it ends up being the same as plugging in the number a. The result ends up being the same as if you just plugged in the number a, not the process. Clear? So people forget about it because they see so few functions that they think that's pretty much true. But it's coincidental. Just the function is so trivial that it's not very sensitive to limits. Okay? So rational functions, if I see the denominator, if I take limit, if plugging a into the denominator will not produce 0, you just plug in a. Good? Let me see if you understand my point. So guys, what is the limit as x goes to 3 of x minus 1 divided by x squared minus 5? Please tell me what's the limit. First of all, do you agree it's a rational function because we use addition, multiplication, and division? What's the limit? All right, no need to simplify it too much. We can see that I can just say the answer is 3 minus 1 divided by 3 squared minus 5. If you really want to simplify it, you can say 2 divided by 9 minus 5, which is 2 divided by 4, which is 1/2. But that's not interesting. Again, guys, what I just specifically wanted to say is 3 minus 1, 3 squared minus 5. Do you really realize what I did? I just plugged in 3. I didn't do anything complicated. I plugged in 3. Now, limits, taking limit, I'm supposed to plug numbers close to 3, but not 3. It's just that the result will be the same. You see, I plug in a number similar to 3, and I will get a number similar to 1/2. The closer the counterfeit of 3 I put in, the better is the counterfeit of 1/2 I will be getting. You understand? And how does it work? We applied limit laws. You understand? So here is that done slowly. So that means go from here to here. That's limit as x goes to 3 of x minus 1. Sorry, of x minus 1 divided by limit as x goes to 3 of x squared minus 5. And I can do that I can do that because that's the quotient law. The quotient law, you see, if you prove the quotient law, then that works. I want you to think of those questions always simultaneously. Is it intuitive to you without any laws? Do you feel that it's kind of, it makes sense that that would be happening? Okay. In other words, you imagine plugging a number that is very close to 3. Okay. Is it intuitive? What happens? And then you can imagine just doing the algebra and applying the limit laws. That's formalism. Okay. Both things I want you to try to train yourself on. Good. So what's the answer? The answer in this case, well, you know, then you see limit of the sum or limit of the difference of limits, and it's a bit tedious, but you just apply all the limit laws. Okay, guys. So again, you're right away thinking, how do you do it on the exam? You have to understand that you follow instructions. If I just ask you what's the limit, you just spit away what's the value you believe the limit is equal to, okay? If I say justify by limit laws, then you justify by limit laws. You understand? So don't do more than the instructions are telling you. Read the instructions always very carefully, and don't do less and don't do more than the instructions. Understood? So if I just said find the limit, you just give me the answer. It doesn't matter. I'm not interested then in how you came up with the answer. If I say justify, and then you start thinking, what do I mean by justify? I try to be clearer, of course, right? I say, let's say justify using limit laws. Then I want you to carry the tedious steps. I will not, by the way. I don't like, you know, carrying the tedious steps. I would try, hope that you will learn. It doesn't matter. I mean, those are natural limit laws, right? You just think about what should happen there, and you know, things will be clear. Yes, good. Now, next question, guys, is this one. Can you see it? X squared minus 1 over x minus 1. Could you please find the limit? X squared minus 1 over x minus 1, find the limit. Be careful. So a bunch of people say it doesn't exist. Is that true? Well, let's see first of all what happens if, again, we are not, remember, you are not plugging in 1. Do you agree? You are plugging values close to 1. So what happens, look at it, this is what I imagine. If I have to kind of carry out conceptually, I think, okay, this would be 1 hat minus 1. 1 hat meaning imitation of 1 divided by 1 hat minus, this is 1 hat squared minus 1, yes? So what do I see? The denominator seems to be an imitation of 0, and numerator seems to be imitation of 0. So it's imitation of 0 divided by imitation of 0. That's a little dangerous. I'm not sure what it is. Good. So then I clear it, and I proceed. Well, I mean, I proceed. Like this. I can factor it out. You agree? I factor numerator as x minus 1, x plus 1. And then I can cancel out the x minus 1. Do you agree? Because x minus 1 isn't really 0. X is not really 1, and therefore x minus 1 is not really 0. Do you see that? So what is the limit? The limit is 2. Is it clear why? I just cleared away what makes it confusing, and I see that the result, what do I mean the limit is 2? I'm saying that if you plug numbers that are very similar to 1, you will see that the numbers that are coming out will be exceedingly similar to the number 2. That's what this means. Good? Let's see if you can carry out the next example, guys. Here is limit as h goes to 0 of 3 plus h squared minus 9 over h. What is the limit? The number h approaches 0. Hamza Sayed, are you here? Hamza Sayed? No? Okay. Jeffrey Zhang. Jeffrey Zhang here?
Yeah, I'm right here. Can you hear me?
Yes. Okay, good. Thank you. Persad Brian. Okay, thank you, Brian. Malloy Janaisa.
Here.
Okay, thank you. Good. All right. Abrodsky Jenny. Abrodsky Jenny. Going once, going twice. Okay. Alam Anaf.
Here.
Okay, good, thank you. Alexandra Jr. Alexandra Jr. Let's see, I was saying something. Okay, Amont Alexander. Okay, great. All right, guys. Bravo, Kevin.
I'm here.
Okay. Okay, good. Let's go on. Sorry. How are you doing, guys? So let's solve this together now. Well, naturally, one way to do that is just to expand 3 plus h squared. That will be, well, I didn't finish the attendance, and don't worry completely, right? I'm just generally trying to figure out who comes to my class and who doesn't, right? Initially, right? So we will be doing a more hardcore attendance once material gets hardcore. For now, I see most of you are here, and I just need a sort of just initial, like, came once to my class. Then it will be all the time coming to my class and thinking about the material. Okay, so we have 9 plus 6h plus h squared minus 9. So that becomes 6h plus h squared over h. By the way, if you want to be assigned for the attendance, guys, after I'm finished with the class, you can stay a few more moments and I will record the remaining ones, okay? Okay, good. So the answer is, once I simplify it, look at it, guys. I simplify it, I can factor out, depends what you're asked. You see, depends what the question is asking. So anyhow, so guys, and for the exam, you just look at the question and then you answer it. Okay, so the answer is clearly 6. Look at it. Expand it, cross away the 9. You have 6h plus h squared over h, factor the h, cross away the h. You have 6 plus h, limit as h goes to 0, that would be 6. Okay? There are going to be more limit questions like this. So this would be now using roots. And that we will possibly talk about a little bit more during the next class. All right, so okay, now let's quickly address, don't worry too much right now about the exam, worry very much about keeping pace in the class and understanding the material. Again, Abrodsky Janie, here or not? Afzal Mahrin, here or not? Afzal Mahrin? Okay, not known. Arutinian Elmira. Elmira? Arutinian?
Here.
Great. Casimir Christian. Casimir
Here.
Christian. Sorry?
Here.
Great. Ergeshev Baizal.
Yeah, I'm here.
Wonderful. Hamza Sayed, here or not? Okay. Ilyasu Dauda, I think here you were worried I didn't mark you. Here you're marked. Ilyas Ibrahim. Ibrahim Ilyas. Give me a few moments, guys. Dauda, yes, I know. Ilyas Ibrahim, not here. Kabarti Moshe. Moshe. Okay. Here. Kika Dorian. Kika Dorian. Okay, great. Klichev Asror. Asror. Klichev Asror. Okay, who else? Okay, well, not too many absences, but we'll see. All right, guys. Let's stop the recording.